Now let me explain what it means to be multivariable. What does it mean to be multivariable? Well, let me take an example from mechanical engineering. It will be about spring design. So suppose I want to design a spring, and spring is, you know, relatively simple thing like this, right? That you can, well, you're supposed to put something heavy on it, and it will hold it. So, what about this spring design? Well, there are some things I can choose to design the spring, and those are going to be, well, let's say, I have to choose the wire, right? And I have to choose the diameter of the wire. Let's call it little d. So that's one number to play with. And I can choose the diameter of the coil. Let's call it capital D. And I can choose the length of the spring. Let's call it L. So I have a few parameters to play with, designing the spring, and I have some goals, right, I want to achieve. So what are the goals? I have to achieve certain strength. Well, let's measure it by some number S, as mechanical engineers do. And there is another parameter. Let's call it avoid buckling. Well, that means that if the spring is sufficiently long and you put some pressure on it, it may just bend over. And that's what you don't want to happen. Right? You want it to remain straight all the time. That's what they call buckling. And avoid buckling is measured by some number. Let's call that number AB. And mechanical engineers know how to compute those numbers based on those given parameters. What else? Safety factor. That is also going to be a number. Let me call it SF. A number that prevents or measures how likely the spring is to break. So, what I want as a spring designer is to play with these parameters to achieve certain parameters on the output. And that means I would call these parameters independent. And those parameters dependent. And what I have mathematically is a way to transform, or rather to compute, those parameters using these parameters. And if I look at mechanical engineers' textbook, there are plenty of formulas about these computations. So there are formulas relating, and what we will look at is that bunch of formulas as one function that takes three numbers on the input and gives you three numbers on the output. So that the value of f, of that function f, add the numbers d, capital D, and L, is exactly the triple of numbers S, AB, and SF. So that is going to be a typical function, multivariable function, from 3 variables to 3 variables. And that is hard to study, I can tell you. So what would be a way to simplify that study? Well, a way to do that would be a very elementary way. Well, let's look at these numbers and let's make this L constant. let me choose the length and fix it. And then see what happens when I change these two diameters, right? Or maybe I can play with it differently. I can fix diameter of the wire, I can fix diameter of the coil, and just play with the length. Right? So what does that mean? It means that instead of looking at 3 independent variables, I'm fixing, say, a couple of them, and I'm looking at just one variable. And then, of course, changing that one variable will make all the 3 variables there change. But I may want to just close one of my eyes and say, let me just look at S and forget about those. And keep track of how S depends on the length. Well, that would be precisely the reduction of that multivariable problem to calculus 1, when you have a function from one variable L to one variable S. And of course, problem becomes very simple because it's calculus 1, but I made a lot of simplifications on the way, right? I forgot, well, I chose a couple of diameters there, and I forgot about a couple of parameters to make it simple. So the whole reason to study calculus 3, this multivariable calculus, is to allow you to stay cool and work with all 3 simultaneously on the input and all 3 simultaneously at the output quickly without those oversimplified reductions to calculus 1. So what we plan to look at is 1 or 2 or 3 independent variables, just to stay simple, right, and not look at into 4, and 1 or 2 or 3 variables in the output. So that's the plan, all right? You'll have to consider all those cases, essentially.